Alright, hello again and welcome to Chemistry B. This is Unit 7. This will be day 1 of our next unit, Acids, Bases, and Salts. Oh my! Before we get to our notes, I just wanted to give you a little preview of acids and bases. So let's watch this video.
Acids and bases have two different faces, two different personalities, and you gotta find out what they're all about. You wanna learn chemistry. Now the first thing you gotta get straight in your head: acids turn blue, litmus paper to red. They react with metals with awesome power. They neutralize bases and taste very sour. Bases are different from acids, it's true. Bases turn red, litmus paper to blue. They neutralize acids, feel slippery on skin. They taste so bitter, and they're called alkaline. Acids and bases have two different faces, two different personalities, and you gotta find out what they're all about if you wanna learn chemistry. Well, there's even more to this wonderful tale, something we call a pH scale. It numbers from 0 up to 14. Those are powers of 10, if you know what I mean. When the pH is 7, then it's a case where the sample is neither acid nor base. But less than 7, it's an acid, we say. More than 7, it's a base all the way. Acids and bases have two different faces, two different personalities, and you gotta find out what they're all about if you want to learn chemistry. Well, acids and bases, now why should you care? Because acids and bases are everywhere. You put them on salads and they get in the rain. They settle your tummy and clean out your drain. So the next time you're sitting under some shade and you're sipping a glass full of real lemonade, you'll notice the sour taste and think in your head, I bet it turns blue litmus paper to red. Acids and bases have two different faces, two different personalities, and you gotta find out what they're all about if you wanna learn chemistry.
Alright, so now that you have that catchy little tune in your head, let's move on. Alright, so day 1, let's talk about the properties of the acids and bases. Okay, don't forget what a property is. It's a characteristic that gives it its characteristics, if you will. So, as we mentioned in the song, acids play an important role. Bases play an important role in our lives. Alright? Batteries, you know, are acids. Citric acid in fruits, antacids, household cleaners, all of those things are the uses of acids and bases, and we have a lot of uses for them, and they are important in our lives. Alright? Properties of an acid. Number 1, they taste sour. Number 2, they will change the color to red of an acid-base indicator. So if the acid-base indicator starts off as blue, it will turn to red. Acids and bases can be weak or strong electrolytes. We'll talk more about that later on. Some of the properties of a base are they have a bitter taste. A bitter taste, kind of like semi-sweet chocolate or baking chocolate. That's that bitter taste. They will feel slippery. So soaps are bases. So that's why dish soap and hand soap are slippery. They are a base. All right. They will change from blue to red. So if you have a blue acid base indicator, or excuse me, a red acid base indicator, it will change to blue. All right. They also can be strong or weak electrolytes in aqueous solution. Now remember what aqueous solution is. Aqueous solution means it is dissolved in water. Most of the time it's dissolved in water. So bases can be strong or weak electrolytes if they are dissolved in water. Okay? Now there's a couple types of acids and bases. Alright? There's a couple types of definitions. And the first type of definition we're going to talk about is a guy by the name of Arrhenius. So Arrhenius is acids and bases. He was the first one to kind of talk about acids and bases. Alright? And he basically said that these acids are hydrogen-containing compounds which will ionize to yield hydrogen ions in aqueous solution. You remember in chemistry A what it means to ion, to be an ion. So if something is ionized, that means it is either gained or lost which subatomic particle? Yes, I'm sure you got this right. It's electrons. They will gain or lose electrons. Okay? If it is a positive ion, that means it has lost an electron. Okay? Don't forget that. So, acids are hydrogen-containing compounds which ionize to yield hydrogen ions, which means it has lost an electron in an aqueous solution. Bases, then, are compounds that ionize to yield hydroxide ions, OH negative, in aqueous solution. So that means Arrhenius base ionizes and it gains an electron in an aqueous solution. So H positive are hydrogen ions and OH negatives are hydroxide ions. Those are things you must memorize. Okay? More about Arrhenius acids. We will distinguish these acids based on the number of ionizable hydrogens that they have. Okay? If they have one ionizable hydrogen, we will call those monoprotic. And an example of this is nitric acid. You see one nitrogen atom there. Excuse me, hydrogen atom, not nitrogen, hydrogen atom right here. Ionizable hydrogen, all right? If it has two ionizable hydrogens, we call that diprotic, all right? And you will see that in sulfuric acid, H2SO4, two hydrogen ions. Now I'm going to stop right here and say, just because there's a hydrogen atom, excuse me, does not make it an acid. So don't fall for that. But if it is an acid and it has two hydrogens, it's diprotic. And you can probably guess what it is if we have three ionizable hydrogens. Yes, triprotic. Okay, three hydrogen ions. Phosphoric acid, H3PO4, is one of those. Okay? Just like I said earlier, not all compounds that contain hydrogens are acids, so you got to keep that in mind. And not all hydrogens in an acid may be released as hydrogen ions. Okay, so if it has that many, doesn't mean all of them are going to be released as hydrogen ions. What determines that? Whether they are in a very polar bond. Alright, these hydrogen ions are then joined with a very electronegative element. So if they are involved in a polar bond, they are ionizable. If they're not, then they're not going to become they're not going to be released as hydrogen ions. Okay. At this point, I want you to draw on your notes page 588, figure 19.2. Draw that there, please. All right, let's talk about Arrhenius bases. An Arrhenius base, let's have an example. Sodium hydroxide, very familiar base. And its common name is Li. L-Y-E, not L-I-E. L-Y-E, very familiar base. Okay? It's an ionic solid that dissociates into a sodium ion and hydroxide ions in aqueous solution. Dissociate means to break apart, or to break away from, or to move away from, or not to be associated with anymore. So what happens is it breaks apart into a sodium ion and a hydroxide ion. So we have an Na and an OH, negative, okay? This sodium hydroxide, or this Arrhenius base, is extremely caustic, making it a major component of products involved in cleaning clogged drains. Now, group 1A elements will react with water to produce bases. Sodium is one of those, okay? And potassium, all those 1A elements, okay? And that is day